this video, we briefly introduce the K and Ka-band shared aperture dual CP phased array based on amplitude-regulated sequential feeding for satellite communication. The reference work can be found on IEEE transaction on antennas and propagation. The traditional design of multifunction circularly polarized antennas heavily relies on complex phase shift networks, which hinders their high integration in K and Ka-band satellite communication. It is essential to develop a novel design method for CP antenna and devise a feasible array configuration capable of dual-band wide-angle scanning. In this work, we introduce a novel ARSF method that enables effective CP synthesis even under large phase gradient deviations from 90 degrees, allowing for broader CP bandwidth without complex phase shift networks. Based on ARSF, dual-band and higher-band dual CP antennas are developed using similar feeding networks, both featuring compact and miniaturized structures. Then, a K and Ka-band dual CP array is constructed by introducing higher band elements into the gaps of dual band elements. The array supports scanning up to over plus or minus 55 degrees in K and K band, while maintaining axial ratio and gain drops within 5 decibels. The ARSF between multiple linearly polarized components is carried out by adjusting the dimension of each slot arm in a traveling wave feeding network to modify the corresponding coupling coefficient A. The axial ratio, expressed as a function of A and the phase gradient phi, is optimized under the constraint S2 1 below minus 10 decibels to maintain efficiency. The blue region identifies viable A1, A2 combinations, simultaneously satisfying the 3 decibel AR and the high radiation efficiency, demonstrating multiple coefficient pairs can achieve CP. For instance, with a 1 equals 0.2 and a 2 equals 0.4, CP performance is maintained across phi equals 37 degrees to 143 degrees, corresponding to over 100% relative bandwidth. Based on the analysis above, a dual-band dual CP antenna is realized using a dual-band metasurface radiator. To address the challenge of wide-angle scanning in uniform arrangement arrays operating in K and Ka bands, the proposed array is configured with 4x4 dual-band elements and 8 higher-band elements, both sharing the same feeding mechanism and lamination stack-up for planar integration. Additionally, sequential rotation is applied to subarrays to suppress cross-polarization. Finally, through fabrication and measurement, the proposed shared aperture array can realize wide-angle scanning range of plus or minus 55 degrees in K-band and plus or minus 60 degrees in K-band and presents good dual CP performance.